So let's look at the arithmetic, how we can do addition and subtractions of two complements number. Um, so for a subtraction, we are using actually two complements to our benefit to change the subtraction to addition. So what I mean by that is, let's say, for example, we have 5 minus 2. We can represent that as 5 plus minus 2. So these are the same thing. This is basically what we are doing. But how we are getting this minus within the number, we are doing a two complement. So a minus b is a plus two complements of b. And that basically takes care of that, and we can just do addition then. If you are doing addition, a positive and negative number, or two negative number, or two positive number, doesn't matter. As long as you're doing the addition, you just do it as usual, as if it's unsigned. You just add the numbers, and the sign gonna take care of itself. If the sign was weird, that's gonna be overflow, and I'm gonna show you an example of that. But basically, to recap, we convert the subtraction to addition by doing the two complement, and for addition we don't need to do anything extra. So let's look at the examples. Here we have a subtraction. We are subtracting this from that number. So this, like under like in English, it means basically this minus that, right? So it's this one minus this one. So this is the negative one, right? So I'm gonna convert this one to two complements to get the negative value of that. So first flip. So we're gonna get one. It's here 1 0 0 0 1 0 1 0. So that's the flip, and then add one. We're gonna get this number. So that's the negative of that. So we already got the subtract into the number. Now we just add them. And basically adding is, so 1 1 1, there is a 0, 1 goes up here. 1 and 1 gonna be 0 1, 1 and 1 0 1, 1 and 1 0 1, and then 0, and then 1 is going outside. That's not the overflow necessarily. That is fine. You just keep the same number of bits that you have. You never change that, because here in this point, two complement, we are not only talking about numbers, we are actually talking about the representation of numbers in computer. And there we always have a limitation of how many bits we have for our number. So that's going to be depending on the data type. So here we have 8 bits, and we have to stick to 8 bits. We cannot go more than, like physically on the memory, we cannot have more than what's like already assigned. So that's a subtraction. For addition, we don't need to do anything. We basically write them and add them. And here you notice that we had 1 1, there is 1 here, and 1 plus 1 is 0, and 1 is overflow. Sorry, it's not overflow, carries on, and that is okay. This is our answer. This is what's gonna be calculated and saved in the memory. This is gonna be ignored. This applies to any representation, like if it's binary or hex, doesn't matter. It's the concept. So when an overflow happens, is that basically we get something, we get an answer that we don't expect. So what I mean by that is, let me through the example. Am I writing on the page? Okay, there you go. So if we have, for example, 4 and 7, and there are 4 bits, let's say if you add them and you get minus 5. So this is questionable, right? We have two positive numbers and we're adding them, and we're getting a negative number. So this is overflow. If we add two positive, we get a negative. So this was the example. That's overflow. If we add two negative and we get a positive, overflow. If adding two positive or two negative number produces 0, that's overflow. Impossible. If you have two positive, you add them, or you add two negative numbers, you cannot get a 0. So if you add a positive and negative, you're never gonna get overflow because you're gonna be always in the range. So those are like the cases that you could get overflow. Two positive producing a negative, two negative producing a positive, or two positive or two negative produces 0. So these are the three cases that are overflow. And this is like very obvious when you do like adding the number. Look, for example, if you have, I'm gonna go like two negative numbers, so 1 0 0 and 1 0 1, and we are talking about two complements here. So what is this one? 1 0 0, that is a negative number. It's gonna be 0 1 1 if you flip them. So it's gonna be 0 1 1, and then add 1, it's gonna be 1 0 0, which is gonna be basically 2 to the 0 1 2. So 2 to the 2, that's 4. But we know it's a negative, so it's negative 4. This one, this is gonna be 0 1 0 plus 1, gonna be 0 1 1, and it's gonna be, this is 2, this is 1, it's gonna be negative 3. So what is our expected result here? It's gonna be negative 7. If we add this, we're gonna get 0 plus 1 is 1, 0 and 0 is 0, 1 plus 1 is 0, and 1 is a carry. So we actually got 1. So we got a positive number. So this is overflow. And this is given that we have 3 bits only to represent the number. If we had more bits, we could do that, right? But only having 3 bits, we cannot represent -7 with 3 bits. That's why it's overflow.